And I want to thank our sponsor, T-Stud. T-Stud is a game-changing technology that solves many different issues, including the core one, which is the transfer of heat through the walls and through the studs. It's a thermally broken insulated wall stud assembly for use in exterior walls and party walls, and is an engineered building product that uses 2 lumber members, an internal truss system, and a frothed-in-place closed-cell foam that has a global warming potential of less than 1 and is EPA compliant for 2020. It provides a 99% thermal break, as well as helps with structural strength, wind loads, sound transmission, both inside and outside, fire safety, mold safety, you name it. It's a traditional 2x lumber that can be installed without extra training. And it pretty much, you can think of any stud package for the house, including the roofing and flooring soon for the T-Stud. 2x6, 24-inch on center is recommended. They're coming out with 2x4s and 2x8s for the passive house folks as well. Go Naked, bare naked stud, cuts costs, and it can be used up to 2 stories with insulation of your choice. So that can be spray foam, cellulose, fiberglass, mineral wool, hemp, you name it. And very excited, they were the 2019 Green Builder Media Sustainability Award winner for structural ingenuity. So go check them out over at tstud.com. And thanks to our second tier sponsor, Niagara Conservation. They make vacuum assisted toilets that we know that work down to 0.8 gallons per flush. And now they have dual flushed toilets that work down to 0.5 as well. We have glowing reviews from affordable housing, multifamily specialists who only use these due to their durability, no extra maintenance, and significant reduction in water bills as water bills are going up across the country. You can also check out their 1.25 gallons per minute shower head and their 0.5 gallon per minute aerator. All of these are WaterSense certified. Go to Niagara.com. All right, well, I'm excited to introduce our speaker here today, and I'm thankful because he took over here last minute for his colleague who couldn't make it. So I'm very appreciative of Mattie Mead. He is the founder and CEO of Hempitecture. While as an undergraduate studying architecture, Mattie connected with a passion for sustainable building methods and materials. To date, his work with Hempitecture has focused on building healthy habitats that are good for the environment and people that live in them. He currently lives in Sun Valley, Idaho, where he enjoys spending time in the mountains and connecting with the outdoors. So with that, Mattie, I will hand it over to you. Please take it away.
Hey, it's so great to be here today. I'm just going to pull up my screen so everyone can see my presentation here. Thank you for that awesome introduction, Brett. And yeah, really exciting to be here. A little bit last minute for me. A colleague of mine was not able to make it, but I am more than thrilled to share with everyone what we are doing over at Hempitecture and the importance of sustainable plant-based building materials. So just to elaborate on Brett's introduction here a little bit, let's put a name to the face. My name is Mattie Mead. I am the founder and CEO of Hempitecture. We are a public benefit corporation, and outside of my work, of course, I'm passionate about architecture, sustainability, but also being outside. I live in Sun Valley, Idaho, which is a ski resort town nestled in the mountains of Idaho, and living in a beautiful place like this where I get to ski and be outside has further underscored the importance for me and our business to protect our environment and to make building materials that are healthy and help build a better world. So we're going to cover a lot of ground today. We're going to talk about who we are, what was our path, give an overview of Hempcrete, where are we now with these sustainable building methods and products, and where are we going? There's a lot of challenges and opportunities associated with this path, and through my some years of experience in this industry, I am well versed in those challenges. And then we're going to share our new product, hemp wool, which we'll call Hemp Wool 101. So as we start this presentation, I'd very much so encourage you to think about what we're talking about as sort of all-encompassing in terms of a sustainable building product and method, but we have essentially two lines of products that we're going to be talking about kind of differently here. So in general, what we do is we specialize in what we believe are the most sustainable building materials on the planet. As I mentioned before, we're a for-profit public benefit corporation. We truly believe that the materials and work that we do benefits both people and planet. So we've vested that mission with this structure. Of course, everyone in the architecture and construction industry knows about the problems with our built environment. And in general, those problems are, our built environment is toxic. Our assemblies tend to trap VOCs, trap moisture, create issues of mold, and unhealthy sick home syndrome is becoming more and more common. Of course, buildings also consume 40% of our energy, and that's approximate, as well as buildings are responsible for about 40% of our carbon footprint. These are some big issues, and these are the issues that we work to confront at Hempitecture by using plant-based building materials. So our solution is using building materials that are non-toxic, that absorb carbon dioxide, and lend to energy efficiency. Our materials lend to energy efficiency because they are highly insulating. Most of what we're talking about today should be considered an insulation method or product. We have a bit of a secret weapon in our arsenal here, and most people, this is where they say, what? Or, they start to doubt what you might be talking about, but our secret weapon here is we use industrial hemp biomass for our products. Industrial hemp is very newly legalized in the United States. Just December 20th, 2018, the federal farm bill legalized industrial hemp in the United States. It had been illegal since 1937 to cultivate industrial hemp, and we were the only industrialized nation on the planet to ban the production of industrial hemp. Our neighbors to the north in Canada have never had industrial hemp as an illegal commodity. And so these building materials that are derived from industrial hemp might be new to the United States, but they're not new around the world. And we're going to go into the history of these materials a little bit more here. But basically the first product, or I'd like to encourage you to think of it as a system that we're going to talk about, is Hempcrete insulation. So Hempcrete is very much so a system. It is not just a one-to-one product substitution. It is a method and means of constructing a home. When we're working with Hempcrete, it is very different from a conventional sort of cladded style of construction. And just like you wouldn't, frame out a house and then decide, I'm going to put straw bale in my house. You start out day one saying, I'm going to build a straw bale house. That's how I'd encourage you to think about Hempcrete. It is a system that has to be considered from the earliest planning stages of your project. It's relatively open source. So what that means is there aren't particular patents protecting Hempcrete. Anyone can essentially batch and produce Hempcrete. There are some elements of it that could be proprietary, such as the binder, and we're going to go into that a little bit further here. But essentially, Hempcrete is a carbon-cured insulation product. There is a bit of chemistry that we'll go over and cover how 1 cubic foot of Hempcrete offsets 7 pounds of carbon dioxide, permanently storing that in the wall composite. There's some challenges with Hempcrete, though. It's artisanal, very, very labor intensive. it is sought after. People around the world are familiar with this building material. It's relatively new, but those who find out about it are eager to implement it, which is an exciting sort of position to be in our industry. But at the same time, it's niche, and it's niche because there lacks the labor and the trade skills here in the United States to successfully install and complete hempcrete projects. And so because of this, we call Hempcrete for the 1%. And I know that sounds terrible, but I don't just mean the 1% of, the wealthiest individuals. I mean this overlapping Venn diagram of 1%. And it's the 1% of people who are sustainably motivated. They want to do something that is head and shoulders better than every other building method that's out there, but they also are financially able. With sort of the newness of this material in the United States, there is a cost associated with this. Most of the material itself has to be imported from other parts of the world, going back to sort of our cultural climate of hemp being just legalized here in the United States. So what is Hempcrete? It's an insulating, breathable, and fireproof biocomposite. I want to underscore fireproof there, and we're going to show data that's very new to back that claim up, but it is indeed a fireproof biocomposite. When I say a biocomposite, I mean two or more things that are natural that are combined together. So when we combine hemp plus lime and water, we get carbon dioxide sequestration. The essence of that is because our binder, limestone, is essentially calcium carbonate. Now, without getting into too many details here, there are some sort of variations of different binders, but generally we're talking about a hydrated, high calcium lime binder. And when it is mixed with water, it seeks carbon dioxide during its solidification process. So while it's solidifying for up to 3 months, it's actually sequestering carbon dioxide from the atmosphere. But that carbon storage that's happening during the solidification of the composite itself is actually only 10% of the overall carbon dioxide sequestration. And so why hemp? Beyond that 10%, the biomass from rapidly renewable industrial hemp offsets about 9.8 tons of CO2 per acre. This graphic is actually from the Rodale Institute, an organization out of Pennsylvania. They're a nonprofit organization working to promote regenerative agriculture and carbon farming. And this statistic is also from the Rodale Institute. So 90% of the carbon storage of the end product itself comes from just the mere cultivation of industrial hemp. We could certainly get in a wormhole about carbon offsets, carbon sequestration, could go all the way back to how much fuel did the farmer use in his tractor. But the point being that we make is that Hempcrete is a carbon storing building material. And there's a reason that this all matters, and this is a chart that is now actually a little bit outdated, but I keep this in here because I got involved in this industry when I was a student studying architecture, and I was really enamored with the mission of Architecture 2030, another nonprofit organization working to decarbonize the built environment. When I learned that buildings and their operation are responsible for about 40% of our energy consumption and carbon footprint, it became my calling. My senior year of college, where you can see a much younger, less bearded version of myself pitching for sustainable building materials. I was presenting across the United States this concept of building with biocomposite building materials. Now, of course, at the time, industrial hemp was legal. Many people joked, oh, you're trying to build houses using something that's a Schedule I substance. But we very firmly believed that, within a reasonable amount of time, industrial hemp would be legal, and we should take note of the examples from around the world, particularly France, UK, Belgium, the Netherlands, and so on and so forth, who are already using these highly sustainable building methods. When I was pitching that concept, it was all about a product concept. a building block that was essentially interlocking, kind of stackable like Legos that could be poured with reinforced concrete to make a thermally efficient envelope that was also structural at the same time. But of course, concepts have to be funded to be real. I did not receive funding for this, but it didn't discourage me because I had an opportunity after college to really start to work with hemp building materials and get some hands-on experience. So I graduated from architecture school, and I had the opportunity to move to Idaho. As someone who grew up in the Northeast, if you had asked me 10 years ago if I'd live in Idaho, I probably would have said I don't know where Idaho is. But I went out to Idaho for the first time to meet with an architect and work on this design build project for a nonprofit organization. This nonprofit organization said, hey, use our property as a laboratory for natural building. We want to show off different methods of sustainability. And the reason that I bring this up is because that is where Hempcrete was at 5 years ago, and for the most part still is. It is relatively niche. It is, forward-thinking organizations or clients who are, eager to do something different, but by no means has it, swept our construction market. Also, being a nonprofit organization, we had to fundraise for this project, and we actually raised money on Kickstarter. We funded the building materials, which actually were imported primarily from Canada to Idaho for this project, basically just based off of a sketch. We worked through a sort of design process. I worked in the architecture studio every day with the architect who was sort of my mentor. And I'm sure some of the architects can relate out there. As a design build program, I was in there doing the drawings myself. And then I was out in the field with those drawings wondering, okay, how the heck am I going to put together what I just drew? Being that we were located in the high altitude region of Idaho at about 7,000 feet above sea level, we have pretty quick turnover for seasons here. Hempcrete, being a biocomposite material that is mixed with water, it has to dry out, and freezing temperatures are sort of a negative for the curing process of hempcrete. This project, because of a necessity, was done with sort of an innovative building method. And I just want to kind of keep in mind that as we go through these projects, each one is going to be indicative of a different kind of building method, so that perhaps you could, at home or at your office or your firm, think about the different ways that Hempcrete could be implemented. So this project, to keep the timeline quick, steady, was done with a panelized building method. We essentially prefabricated these panels on site, installed the hempcrete in them, stood them vertically, allowed them to cure while the work was happening on site. We had, the concrete foundation already being put in place, allowing us to skip that sort of 3-month, curing time, which certainly is a limitation and challenge when working with hempcrete, to ultimately having our envelope that would be encapsulated with a post and beam frame erected by winter time. Not to mention, this property was located over a mountain pass road that's only open probably about 7 or 8 months of the year. So getting all this material there, having everything built and done in time for winter was absolutely imperative. Through this learning experience, this project ultimately became a community building for this nonprofit organization that was opened in 2016. This building project for me put into perspective really the challenges of working with hempcrete, let alone being sort of in a rural job site, but the challenges of working with hempcrete, getting the materials to your project site. How does the material integrate with a structural frame overall? And then what are the finishes for hempcrete? With it being a vapor open breathable wall system, how do we finish that out effectively? The project itself was a tremendous learning experience for me. And following that, I realized if I'm going to apply this sort of niche new building material to conventional building, I have to learn how to actually build buildings. While I thought my architecture program equipped me for that, And to a great extent, my architecture program really, expanded what my sense of design and architecture is. It didn't teach me hammer and nail. So learning hammer and nail, working with a construction firm in Sun Valley, I soon thereafter had the opportunity to work on a different project.
Thanks for watching. Please continue to watch the next part of the session to complete the course and get your continuing education credits. Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.